Okay, here are the 4 I asked you to do by yourself. I am going to go through them rapidly, so to say, because the last video was very lengthy. I'm going to rewrite this in slope-intercept form, being very careful not to drop the negative sign in front of the y. So I end with y equals x minus 2. Start at the origin, 1, 2, negative is my beginning point. I have only one x there, so I'm going to go up 1, right 1, up 1, right 1. Again, I still like to use many dots so I can make a nice straight line. We're not playing connect the dots, so please make sure your lines go through. The next one I will also write in slope-intercept form, so 3y minus equals negative 2x plus 9, dividing by 3, and I get negative 2/3 x plus 3. So I'll start at the origin, 1, 2, 3, down to 1, 2, 3, 1, 2, 1, 2, 3, wait, 1, 2, 1, 2, 3. That's all I can fit in that direction. And I will use my straight edge, so to say. Okay, I see that the lines have crossed in one location, right there. That means there is one solution. And it is at the ordered pair 1, 2, 3, 1. So 3, 1. 3, 1 will work in this math problem. 3, 1 will work in that math problem. That is the only ordered pair in the world that would work in those two equations. Okay, I'm going to write this in slope-intercept form. So 4y equals negative 2x plus 2. Divide by 4. I did that kind of in my brain. We're working with 1/2. That will be a bit challenging, but that's okay. So I start at the origin and I move up 1/2. Then I'm going to move down 1, right 2, down 1, right 2, down 1, right 2. Don't really like working with fractions, but I'll do the best I can. Got my neat little straight edge here. With the next equation, I am also going to put that in slope-intercept form. So I subtract 3x from both sides. Oh, I'm going to divide by 6, so I get negative 1/2 x plus 1/2. Ooh, what do you notice right away when I look at this equation and compare it to that equation? I notice they're exactly the same. If I was going to graph, you don't have to double draw lines on it. If you want, you add an extra arrow. This would have infinitely many solutions. Any ordered pair will obviously work in this math problem and that math problem. They are identical. I'm going to rewrite this first one in slope-intercept form. Y-intercept of 4. So 1, 2, 3, 4. I have a slope of negative 1, so down 1, right 1. And there's that one. Now I'll do the same with the second one. What do you notice here? Are you noticing anything? Well, I'll graph it. I'm going to start at the origin, and I'll start at +1, the beginning point. Then I move down 1, right 1. Oh yeah, the same slope, same rate of change. Therefore, they're parallel. These two lines, if I can draw straight, will never ever cross. Therefore, there will be no solutions. Because they never ever cross, they will never have a point in common. There isn't a spot in the world that these two would cross. And the last one. I'm going to write it in slope-intercept form. I will not lose my negative sign in front of the y. Divide by -2. So I will have -1. And then I move up 1, right 2, up 1, right 2. Using my handy dandy straight edge here. All right, repeat the process for the next one. I would subtract 3x from both sides. And now I start at +6, so I go to the origin and move up 6. 1, 2, 3, 4, 5, 6. And then I move 1, 2, 3, right 1. 1, 2, 3, right 1. Okay. Getting out that handy dandy straight edge. All right. So what I noticed, these points have, or these two lines have one point in common. That means there is one solution, and obviously you've seen me abbreviate, you may abbreviate. Here's the origin. It crosses at the ordered pair to 0. So 2, 0 would work in equation number 1. 2, 0 would work in equation number 2.